we've looked in great detail at measurements in terms of both the numbers and the units that go into them. Now we need to look at one more detail, which is what happens when you have a perfectly usable measurement, but it's not in the units that you're comfortable working with. This happens all the time. You might have experienced this if you've ever driven a car or a truck over the border from America into Canada. In America, we measure our speed limits in terms of miles per hour, whereas in Canada, they are measured in kilometers per hour. Now, some speedometers display both of these numbers, but if yours doesn't, and you run into a sign that says 100 kilometers per hour, you need to be able to convert from kilometers to miles so that you still have usable information. That's not a real technical example, and as long as you can get it approximately correct, you're probably fine. But in more technical laboratory and medical settings, we do a lot of conversions. It might be something as simple as having a patient medication that's prescribed in terms of grams, and we need to change it into milligrams. Or, even more technically, what happens if a dosage is given in milligrams per kilogram of body weight, and you only have your patient's body weight in pounds? That's another example of where we'd use a unit conversion. Perhaps even more interestingly, though, some things that we don't consider to be true conversions, we can use the same type of math to solve. For instance, if you have a patient that's been given an IV. An IV is often given in terms of several different units, both the concentration of the solution in the IV, maybe the patient's body weight, the amount of time the patient will be on the IV, and any medication that's being added to it. Each one of those is a piece of information, and in fact you can use one to convert to another so that it's a more useful piece of information. Basically, in their most simple sense, unit conversions involve any calculation where you start with one unit and you end with another. So it could be simple, like starting with pounds, ending with kilograms, or it could be much more complex, starting with a dosage for a medication and ending with the amount of time the patient must be on the medication to receive that dose. In order to make all of these different conversions, we're going to use something called a conversion factor. And a conversion factor is really just a fancy word for fraction. In other words, it's a mathematical form of something that has a top or a numerator and a bottom. So let's look in detail at conversion factors and then use them to do some conversions. We're going to start with a very simple example. Depending on how fresh your math classes are in your head and how long ago you took them, this might be review or it might be something you'll be glad to have me go over. So if this is review, that's great, but bear with me. Any two units, any of them in the whole world, can always be related to each other through a fraction, which is what we call a conversion factor. And these two units could be technical, like relating pounds and kilograms. They could be less technical. And as you already have figured out, I like to start with the less technical. So here's an example of something that can be written as a conversion factor. Generally, the cars that I'm familiar with need 4 tires to equip one car. I know there's exceptions out there, we won't go into them. So if you need 4 tires to equip one car, a lot of times we can express this information as a conversion factor. The way that we do that is we write it as a fraction. 4 tires over 1 car. Or it's completely correct to reverse this and write it the other way. 1 car per 4 tires. Notice that in each one of these cases we have a numerator, that's the thing on top, and a denominator, which is the thing on the bottom of the fraction. Now this is obviously not real technical, but you're going to use the same type of format when we do deal with more mathematical conversions. For instance, in 1 kilogram, there's 2.205 pounds. Go ahead and write both versions of conversion factors that can be used for this. Pause the video if you like. Okay, so to write 1 kilogram in 2.205 pounds, one way to do it would be to write 1 kilogram in the numerator and 2.205 pounds in the denominator, or you could also flip this upside down and do the inverse, 2.205 pounds, and I'm using the abbreviation, but you don't have to, you could write it out if you want, and on the bottom in the denominator 1 kilogram. What's significant about this is notice that it's equally correct to write the one on top or the one on bottom. And as we'll see in a few minutes, sometimes there won't be a 1 at all. Whether you write the number in the numerator or the denominator, it depends on the actual question for which one of these forms is going to be correct. So keep in mind there's no rule about whether the 1 has to be on the top or the bottom. It's just going to depend on the context. This is how we write conversion factors. Now let's look at how we use them to actually do a calculation. So now we know that we're going to have to use these conversion factors. Here's how we actually put them to use. We're always going to start by writing what we have. And what I mean by that is start with the measurement in units that you don't want or that you're trying to change. To make this general, I'm just going to call this A rather than starting with an actual calculation. So I'm going to start by writing down A. What I'm always going to encourage you to do in this course is then to immediately write times with a line. The line represents the conversion factor that I'll be filling in. I'm going to multiply by the conversion factor because we want to make things cancel. So here's the only other thing you have to try to remember from when you took your math class is how do you make something cancel when you multiply? Well, to cancel the unit you don't want, it always has to go opposite from where it is in the problem. And what I mean by that is this A, because I just wrote it, basically is over an implied number 1. In other words, the A is in the numerator. So if I have a conversion factor that says A is equal to B, I need to make A cancel. So should I write it on the top or should I write it on the bottom? Well, to make it cancel, since the A is already on the top, I need to write it on the bottom. That means A will go on the bottom, B will go on the top. Remember on the last slide, I said we always have 2 different ways to write a conversion factor. The numerator could be one of 2 values, and then the other value goes in the denominator. Well, here's how you decide which version to use. You always have to make the thing that you don't want cancel. So here A will cancel, and my answer will be in B. Let's try applying this to an actual example. Here's a simple conversion. My dog, Taj, one of my 3 dogs, weighs 52 pounds. Convert his weight to kilograms. And then I gave you the conversion, 1 kilogram equals 2.205 pounds. If you're feeling a little bit overwhelmed or you're starting to get a little bit nervous, I thought I'd help you out by giving you a picture of Taj before he weighed 52 pounds. There's Taj. Okay, so go ahead and try this calculation. If you're feeling a little bit lost, it's okay to not pause the video and just follow along, but if you want, go ahead and try it on your own. So my dog Taj weighs about 52 pounds. Convert his weight to kilograms. Start by writing down what you know. I know that Taj weighs 52 pounds, so I'm going to write that down first. Remember that one of the great ways to get started on these problems is to write a multiplication sign and a line, because that'll always be the case when you do a conversion, and it doesn't ask you to have to figure anything out right away. What I really like to do is not worry about numbers until I have to. All I'm going to look at is the fact that I have 52 pounds. Now, remember, if it helps, feel free to draw a line and put this over 1. You absolutely don't have to, but some people find it helps them remember this is actually a numerator. Because I want to get rid of pounds, pounds is already in the numerator, so I'm going to have to put it in the denominator to make it cancel. That means whatever I'm looking to find is going to go on the top. Notice I didn't write down any numbers yet. All I did is figure out where the units have to go. So this is going to make pounds cancel pounds, and it's going to give me an answer in kilograms. Now I can plug in the numbers. According to this conversion factor, there's 1 kilogram in 2.205 pounds. So I find kilograms and I write a 1 next to it. Then I find pounds and I write 2.205 next to it. Now, to do the math, I multiply across the top and I divide across the bottom. I take 52 times 1 divided by 2.205. And of course, you can leave out the 1 if you want because it won't change your calculation. Your calculator tells you the answer is 23.582 7, 6, 6. Oh, I'm getting so bored writing this number, but that's okay because I know I'm going to have to round it. So we'll get to that in a second. In the meantime, 52 pounds times 1 kilogram over 2.205 pounds gives us an answer in kilograms. Now, if you haven't already, round this final answer so it has the correct significant figures. Go ahead and pause the video. To determine the correct number of significant figures, I have to look at the values that I started with. Don't be intimidated by the fact that there's quite a few values here. We're just going to look at them one at a time. The first thing to realize is this is a multiplication problem, and because of that, I'm going to look at the number of digits, not the number of decimal places. All conversions will always follow this rule. We look at the number of digits or the number of significant figures. Don't worry about decimal places. So let's go one at a time. The number 52 has 2 significant figures, so 2 sig figs. This one is just something I put there, so I'm going to kind of ignore it. Let's go to 2.205. This number has 1, 2, 3, 4 significant figures. Okay? Finally, let's look at this number 1. Now, strictly speaking, this number would appear to have 1 significant figure. But here's where I have to ask you to use some common sense for a second. Do you think that there are 2.205 pounds in about 1 kilogram? Or do you think there's 2.205 pounds in exactly 1 kilogram? Well, we're scientists, so usually we would do conversions as exactly as possible. So in all cases where you see a conversion with a number 1 in it, this really means 1.00000, as many zeros as you feel like writing down. In other words, this is actually infinitely precise. It really means that we have a value that's truly and exactly 1. Or in other words, we get to ignore it for the cases of sig figs. For all conversions, when you have something over 1 or 1 over something, ignore the 1. It won't limit your precision. So let's look at what we do have. 2 sig figs here, an infinite number of sig figs here, and 4 sig figs here. So I need to round my final answer so it has 2 sig figs. So I get to cut off all of these until I get to 2. And the last number I cut off was a 5, so it will round up. So I say 24 kilograms. If you think about it, how we rounded this actually makes some sense. I started out with the number 52, so it seems reasonable to answer with the number 24. At least more reasonable than saying 23.582766, etc., because that seems to imply a great degree of precision. You can use conversion factors for many different settings, and one of those settings is if you want to convert between metric units. We've already talked about how to do this simply by multiplying and dividing or moving the decimal place, but I just want to show you an example of how to use conversion factor setups to do a metric conversion. Let's take the example of a human heart which weighs 297 grams. Okay, so this is a smaller heart than we dealt with in a previous problem. I'm going to ask you to convert it to kilograms. As you do this, you can try doing this any of the 3 ways that we've discussed. The first way is you can just move the decimal place. That's fine. The second way we already talked about is you can multiply or divide by 10 to the correct exponent. The third way, and what you can try if you already feel okay with the other 2 methods, is try using a conversion factor. I'm going to use a conversion factor for this one since we've already been over the other 2 methods. Take a second, pause the video, and try this problem. Alright, so you may have tried several different versions of this, but I'm going to show you how to do this first in terms of conversion factors. In order to do that, I start by writing down what I know, 297 grams. The next thing I do is I write a multiplication sign times a conversion factor that I'll have to fill in. Here's where this is different from examples where you go from kilograms to grams. In the metric system, you have to have memorized what the conversion factors are. And that's not really as scary as it sounds. It's just based on knowing how many times bigger or smaller one prefix is than another. Start by getting your units in the right place before you worry about numbers. If I have 297 grams, in order to make this cancel, I'll write grams on the bottom, and that means kilograms is going to have to go on the top. Now, to fill in the conversion factor, here's where the metric system matters. I have to know how many kilograms in a gram or how many grams in a kilogram. And there are about, I can think of at least 6 different ways to write this that are correct, and I'm sure there's more. The way that I think of it right away is the fact that there are 1,000 or 10 to the third grams in a kilogram. Other ways you could write this are to say that there's 10 to the negative 3 kilograms in 1 gram. Or you could say that there's 1/1000th of a kilogram in a gram. There are many other ways to write this, but as long as you get one way correct, you don't need to worry about the other ways. There's 1,000 grams in a kilogram. This is going to make my grams cancel to give me kilograms. And 297 grams divided by 10 to the 3 gives me 0.297 kilograms. Let's check our rounding and make sure it's correct. I started out with a value that has 1, 2, 3 sig figs. Now let's look at my units to see if I have to round, or rather my unit conversion to see if I have to round. Again, whenever we see the number 1, we know that this is infinitely precise. So in other words, I don't have to worry about the number of sig figs. And for that matter, this number 1,000, think about the metric system. Do you think there's about 1,000 grams in a kilogram? Or is the metric system defined as having exactly 1,000 grams in a kilogram? Well, you guessed right if you guessed that it's exact. So this is also infinitely precise. Don't panic. Here's how you know. If it's in the metric system, your conversion is always infinitely precise. I'm going to use the symbol for infinity. So always infinitely precise. In other words, this is good news. If you're doing a metric conversion, look at how many sig figs you started with. Make sure you end with the same amount, and you'll be right every time. I started with 3 sig figs. In the end, I have 1, 2, 3. This 0 doesn't count, so I'm good. This is my final answer, 0.297 kilograms. The examples we've just looked at are what I would call simple conversions. And I don't mean to imply that they're necessarily easy, it's just that they only require one step or one conversion factor. The reason for that is that you can change directly from something like pounds to kilograms or grams to kilograms. Many times, however, we're going to deal with conversions that are more complex, meaning you need more than one relationship to solve them. This happens when you don't have a direct relationship between units, or perhaps if you have more than one unit that you need to change. Let's look at an example. An example is if I have to convert 45 miles per hour to kilometers per minute. Notice that here I have 2 different units in my unit conversion. I have 45 miles per hour. So miles is a unit and hours is a unit. Let's start by writing down the information that we have and then look at how we can go about solving the problem. You may be tempted to write 45 miles per hour the same way it's written here, which is miles/hours. The difficulty with that is now my numerator and my denominator look like they're on one line, so that's hard to work with. So I don't recommend writing your information that way when you start a calculation, although it's fine in other settings. I also don't recommend that you use any abbreviations. For instance, if you wrote 45 miles per hour, that gives us the same problem. All of our units are squished into one line. So while both of those are obviously okay to write in a lot of settings, they're not the most helpful way to write a complex unit when we're about to do a conversion. Here's what I recommend doing instead. Take the 45 miles per hour and break it out into a fraction. This really means I have 45 miles, and then in a fraction I would put that over 1 hour. So even though this looks a little more complicated, it's going to make our life a little simpler because now I can easily see what's in the numerator and what's in the denominator. In order to do this conversion, we're going to change our units one at a time. So we have a unit of miles and we have a unit of hours. You can convert either one first. There's no wrong answer. Since it's on top, I'm going to choose to convert the miles first. In this question, it's asking me to change from miles per hour into kilometers per minute. So my miles has to change to kilometers. My hours has to change to minute. Let's focus on miles to kilometers first. As I'm always going to remind you, when you don't know where to start or when you're just starting out, write a conversion factor setup, a multiplication sign, and a line. I'm going to ignore the 1 hour right now because I'm not working with it and focus on 45 miles. To make miles cancel, where should I write it in this conversion? Well, miles is in the numerator, so right away I want to write it on the bottom in the denominator. I'm not going to worry about putting any numbers in yet. Miles goes on the bottom. What are we trying to change miles into? Well, we set up here miles needs to become kilometers, so I'm going to write kilometers on top. Now it's okay to go back and add information. You probably don't have miles and kilometers memorized, but here's the information given to you. 1.605 kilometers, 1.605 next to the km equals 1 mile. So 1 mile. This is going to make my miles cancel, and in the numerator I'll now have kilometers. You could stop and do your calculation here and then continue on later, but to make it as easy as possible, I actually recommend continuing the conversion and then doing all the calculations at once. It actually makes it less likely you'll make a mistake. So let's try that. I've already eliminated miles and changed it to kilometers. If I solve right now, I'd have kilometers in the numerator and hours in the denominator. What I really want is not hours in the denominator, but minutes. So I'm going to do another conversion. As I do this conversion, ignore the stuff in the middle. Just pretend it's not there at all. We'll block it out of our minds. So I'm looking at this and I see that I have 1 hour. I don't want hour in my final answer and I need to make it cancel. So in my conversion, do I write it on the top or the bottom? Well, hours actually starts in the denominator. So to make it cancel, I need to write hours on top. To change hours into minutes, minutes is now going to go on the bottom. You probably know this one off the top of your head. In 1 hour, there's 60 minutes. And by the way, that's a 60 that's exact. So if you need to put it there, put another 0 to remind yourself. If you weren't sure about that, that's always something I'm happy to clarify for you. So 45 miles will cancel to become kilometers. 1 hour will cancel to become 60 minutes. Once hours cancels, I'm left with just minutes on the bottom. Now I'm ready to do my actual calculation and to round. So I'm going to take my calculator and I like to multiply across the top. 45 times 1.605 times 1 gives me the answer of 72. I think. Let's see, 45 times 1.605 gives me 72.225. On the bottom I have 1 hour times 1 mile times 60 minutes. So 1 times 1 times 60 gives me 60. And when I divide, I get a total answer of 1.20375. So 1.20375, let's clean that up real quick so you can read it a little more easily. That's my answer in terms of kilometers on top, minutes on bottom. And now I have to choose how to round it. If you haven't rounded it already, take a second and go ahead and try. Okay, so 45, again, this and this are multiplication signs, so like all conversions, I just look at significant figures. I have 2 sig figs in the number 45. Here's a number 1, so it's infinitely precise. I have 4 sig figs in the number 1.605, and again the number 1 is infinitely precise. Here's infinitely precise, and 60 minutes is infinitely precise because there are exactly 60 minutes in an hour. So overall, I have to worry about the fact that I had 2 sig figs to start, so I'm going to round this to 1.2 kilometers per minute.